double slit experiment with electron. Again we had a 2 slit obviously, and we had a screen here. So slit 1, slit 2, we named that one. Here we were sending what you call electrons, again from a very large distance, so that electron beams will be practically parallel. Yeah, we are sending electron from a very large distance, so that it's almost parallel. Let me say like that. Okay, equally probable. You are shooting electron so that it is equally probable here. Okay, so keep your volume off there. Okay, we have seen that when we close slit 2, when we expose only slit 1, we got this pattern, isn't it? We got this pattern. When we close the slit 1, when we expose only slit 2, we got this kind of pattern. Is that okay? We call this one as P1, we call this one as P2. When we, again look at here, I am not moving the screen. When we expose both slit, okay, when we expose both slit, so we got this kind of pattern. Okay, approximately. Okay, so we call this one as P12 when we expose both of the slits, that we have seen. Okay, and now look at here. We say again, we got how to find how P1 to relate it to P1 plus P2, isn't it? Again, so prior to P1, so prior to this probability, we need to define a quantity, more fundamental quantity. We call that one as probability amplitude. Am I right? Psi 1 mod square. So prior to this P2, okay. So prior to this P2, we need to what you call define so other fundamental quantity, that is psi 2 mod square. We call this one as psi 1 is the translational state of the particle which is passing through slit 1. Psi 2, which is a translation state of the particle which is passing through slit 2. It is probability amplitude. But what does it say? It talks about a state of a particle, just like ground state of hydrogen atom, first excited state of hydrogen atom. Okay, so it talks about the state of the particle. So then, so we got, when we keep this one unobserved, when we are not disturbing the electron, what we got? So the state of the what you call so electron. So even the same is true for single electron experiment. Okay, now so the state of the electron is psi 1 plus psi 2. We call this one as superposition state. Now look at here, the word superposition contains two things which are superposing. Okay, if you are worried about that word, go for other word which is linear combination state. That is that we are going to use in case of linear algebra. Okay, suppose if you are worried about again, so you are trying to say that electron is superposed with itself, isn't it? Even Dirac word, isn't it? So Dirac also said the same thing. So I am not feeling comfortable with that one. How one superposed with itself? That itself is what you call unconvincing. Okay, so that's why again, if you are worried about that word superposition state, you go for linear combination state, because these are linearly combined. That's what we use in case of pure what you call so linear algebra. Is that okay? So we call this one as superposition state. We are defining the state for a one particle. Okay, one particle can be in psi 1 state, one particle can be in psi 2 state, one particle can be in psi 1 plus psi 2 state. You can call it as linear combination state.
So if I have another slit, if I have 3 slits.
Yeah, psi 1 plus psi 2 plus psi 3. One more state. Again, remember, I am only worried about the electron which are received on the screen. Okay, so there are, if you start talking about states of the electron which are sent here, there are some states which are hitting the walls or other side other than these holes. Okay, I am not worried about that one. Again, just see it from what you call this screen. Okay, whatever the electron receiving here, so those are in this state. So mod square will give the what you call linear combination state. Okay, so that P12 is equal to mod psi 12 the whole square, that is mod of psi 1 plus psi 2 the whole square. This will give us P1 plus P2 plus 2 root P1 root P2 cos delta. Is that okay? Now look at here. What I told here is particle can be in again, how do you know that particle is in superposition state? Suppose if particle which are sent here, suppose if particle sent here, if they are either in this state or in this state, okay. Again, our logic says particle should be either pass through slit 1 or slit 2, isn't it? Isn't it? So this is quite difficult to grasp, isn't it? So don't join after what you call 5 to 10 minutes, okay? Join before 6:05. Yes. Now look at here. Again, so our classical ideas or our logic, our common sense says that it should have passed through either this one or this one. So that means if you send 1000 electrons, okay. So again, maybe 500 electron. Again, our logic says 500 electrons should be passed through slit 1. Other 500 approximately. Okay, I am not saying again. It always happens 50-50. Okay. So maybe so you may need to take millions of electrons to show that it is 50-50. Okay. So other 500. So they may what you call have this state. Okay. So they may pass through slit 2. Not what you call first 500 pass through slit 1, second 500 pass through slit 2. I am not saying like that. Okay. So maybe alternatively or so first 2 will pass through slit 1, next one pass through slit 2. So third one pass through slit 2, fourth one pass through slit 2, fifth one pass through slit 1, like that. Anything can happen here. Okay. Now look at here. Now again, if our common sense is saying that whatever the electrons received here, it should be either from this one or from this one, isn't it? If it is so, if I shoot 1000 electron, okay, so 500 of those, so suppose if I receive 1000 electron on the screen, okay, so because all 1000 electrons shooted, that may not reach here, some may hit this one, okay, so practically. Now, so if I count 1000 electrons which is reaching the screen, among them, if you say 500, approximately 500 of them so passes through slit 1, other 500 passes through slit 2, okay, all these 500 passes through slit 1, it will produce this probability distribution, obviously, isn't it? All other 500, it will produce this probability distribution, and your resultant should be P1 plus P2, but you are not getting this one. Are you getting my point? So that's why when you keep it unobserved, look at here, I am talking about when you are not observing, okay, when you are not observing. So when you are not observing, you are getting this pattern. When you are not observing, it is wrong to say that electron passes through either of the slit. When you are not observing, it is wrong to say that electron passes either through slit 1 or through slit 2. It is wrong to say when you are not observing, electron is in either this state or this state, whatever electron received on the screen. When you are not observing, electron is in this state, superposition of states, superposition of translational state, we say like that. Again, we call these things as translational state. These are not energy states actually, okay. So we shall see later, we got energy eigenstates and all later, okay. Yes, speak out.
Can you please repeat that sentence again? I didn't understand.
Which one? Again, wait a second. What I was saying, yeah, so what I was saying? I always think ahead, okay, I mean, what you call, yeah.
No, you are saying that when we not observe.
When we are not observing, okay, our common sense says whatever received on the screen, it should have passed through either slit 1 or slit 2. Single electron experiment, okay, so take single electron. Okay, if that is so, this would happen, isn't it? If suppose if I receive 1000 electrons there, so 500 electrons should have passed through slit 1. That's our logic says, am I right? If you receive 1000 electrons, among them, so again, so maybe alternatively or whatever, so 500 electrons, around 50% of them have passed through slit 1, other 50% have passed through slit 2, isn't it? If that was happened, okay, I am not talking about observation, okay, I'll come to that one later. If that happens, if 500 electrons were, if 50% of them were from slit 1, if 50% of them were from slit 2, then look at here, that 50% will produce this pattern, other 50% will produce this pattern, and merging the pattern, that's what we need to observe, which is continuous, am I right? Merging of these two patterns. But we are not observing this one, we are observing this one. So this is because of this one. So that's why when you are not observing, what is the state? this state, superposition of translational state. Translational state, okay. Later we talk about energy eigenstate, spin state, like that, okay. We have different states here, okay. The state of the electron, okay. The state of the electron which is received on the screen, okay. Possible state of the electron which is received on the screen. I am not worried about other electrons which are hitting other part of this one, okay. State of the electron can be psi 1. What is this one? I told translational state. So that pass through slit 1. Am I right? I am not writing full sentence, okay. So state of electron, that can be psi 2. That means translation state of the particle that pass through slit 2. Again, state of the electron can be superposition of these two or linear combination of these two. Now you can't say this is a translation state. Which translation state you say? It is superposition of translation state, linear combination of translation state. This you can't give any words for this one, isn't it? Just like I said, yeah, this is the translation state of electron that pass through slit 1. So psi 2 is the translation state of the electron that pass through slit 2. Remember, this psi 1 and psi 2 you will get to know. Okay, this psi 1 and psi 2, these are exactly similar to our wave optics. Again, after solving Schrodinger equation, okay, you will get to know these translation states are like this: e power I k dot r minus omega t only. So you will get to know. Again, this has definite momentum. It has one propagation direction. Okay, that momentum is equal to h bar into k. Again, it will satisfy your de Broglie hypothesis. Suppose if you write k is equal to 2 pi by lambda, is that okay? Mod k is equal to 2 pi by lambda, where lambda is your de Broglie wavelength here. Is that okay? So this is very exactly similar to the what you call functionality. Maybe terms are different. We again h bar into k, we need to define it as momentum. We don't define momentum for a wave, isn't it? But lambda, again we can define lambda here, but it is de Broglie wavelength here because we are talking about particle here which has a mass. We are going to solve Schrodinger equation. In Schrodinger equation, mass also comes actually. Okay, but this functionality, it exactly looks as similar to I have written the same equation, am I right? E power I k dot r minus omega t in the last class. So again, our wave optics also gives the same thing. Okay, now quickly. So state of the particle can be psi 1, state of the electron which are received on the screen, okay, that can be psi 2, state of that one can be psi 1 plus psi 2. If superposition is a misleading term, use linear combination state. Okay. Yes.
So why it is called translational state?
No, because it talks about some direction of motion, am I right? Path. What you call it has a definite momentum state actually. The translational, isn't it? It is moving. Rotational state, translational state, energy state, spin state, like that. Is that okay? We are going to use this word later, okay? Again and again. Yes. There is no classical counterpart. Better not to what you call leave it as it is. Call it a superposition state or linear combination state. Remember, so if this was not proceeded in this way, suppose if we are happy with old quantum theory and what is that, de Broglie wavelength or whatever, okay? So your quantum computation would not be there. Old quantum theory will never talk about superposition. It talks about only quantization of energy. Superposition state, linear combination state, like that. Now we have a quantum computation, isn't it? So because of these quantum ideas. So that's why we need to evolve the theory, so that we can predict new phenomena. We can find new phenomena, isn't it? Not only explaining earlier one. Is that okay? So that is the basic idea. I hope you got my point, okay? So better not to what you call think too much about this one, because it will make it complex and complex. Okay, what is that one? Whether it pass through both slate, whether it will pass through none of the slate. Again, questions comes again after secondary question comes. Okay, is that okay?
Yes.
Yeah. So now I'll go to measurement. Okay, so you keep observing YouTube. Okay, now look at here. Suppose if you observe, if you observe the electron which are reaching this screen, if you observe some by some switching on light or something, okay, suppose you are sending photon of very low momentum, let me say like that, so that electrons are not much deviated but they are disturbed, okay. Let me talk about the disturbance little later, the necessary disturbance, okay. I'll talk that on a little later, okay. So now look at here, when photons so when electron stream comes, I am going to hit that one with a very low momentum photon, okay. Very low momentum means h nu by c, isn't it? H nu by c, nu should be very small, whatever, okay. I'll somehow so take care, but it may not be possible, okay. So whatever the photon you hit, electron will be disturbed here, okay. It will be disturbed by its path itself. But I'll not go to that how practically I do measurement, okay. I'll just say I did measurement, I found that either electron pass through slit one, or I again look at here, if you do measurement, you will get electron is in this state or in this state, not in this state. If you keep it unobserved, then only you get this state. If you do measurement, either you get this state or you get this state. If you do measurement, if you do observation through which slit electron is passing through, you will get either again it is passing through slit 1 or it is passing through slit 2, which is reaching the screen. The electron which are reaching the screen, if you try to observe through which slit it have passed through, so it passed through, you will get one of these two, okay. You will get either slit 1 or slit 2. Once you do observation, once you got to know that electron, suppose if you take 1000 electron, you did measurement of all 1000 electron, then what you will get, you get around 50% of them pass through slit 1, other 50% of them pass through slit 2, isn't it? That's what you observe obviously. So then your pattern, this pattern will be lost, because all 1000 electron whatever you have whatever reach the screen, those are all observed one, okay. You have already observed through which slit it is passing through by some arrangement, some experimental arrangement. So then again 50% of them will produce this pattern, 50% of them will produce this pattern, and your resultant pattern when it is observed, shall I write here? I am not moving the screen, okay. Again I can draw at 1. If you observe, you will get this one, which is just merging of these two actually, okay, which is just merging of these two. That is when observed, so through which slit electron passing through. So what is your answer? Either psi 1 or psi 2, isn't it? Either slit 1 or slit 2, so that your P12 is equal to P1 plus P2 here. In this case, your P12 is equal to P1 plus P2, or I better write like this, mod psi 1 square plus mod psi 2 square, okay. So in this case it was mod of psi 1 plus psi 2 the whole square, which is just merging of these two patterns, that's equal to P1 plus P2. Is that okay? When you observe, you will get, again when you observe the electrons which are reaching the screen, you will get state of the electron either psi 1, state of the electron either psi 2. We call this one as collapsing of the wave function. If you are not observing, it is in this state. If you observe, it will collapse to one of the state instantaneously, very instantaneously. I'll come to that point later, okay. Now better not to think much about collapsing of the wave function, how it happens and all. I'll come to that one in the pure quantum mechanics, okay. So this is quite logical now, isn't it? If you observe, you will get any of these, then definitely pattern will not be this mod square of this one. Pattern will be mod square plus mod square. So pattern will be merging of these two. Is that okay?
After observation, it becomes like bullet expression, that experiment, right?
Yeah, no. In bullet experiment, it was like that, but it was very close to each other. Okay, I didn't quoted that one. In bullet experiment, so again, it has similar shape, but these were very close to each other, so that you can't differentiate. unobservable. Fringe width are so small that they are unobservable. So what is fringe width formula for a double slit experiment? Beta is equal to lambda capital D by small t, isn't it? Now look at here, for a bullet lambda is too small, so small, isn't it? De Broglie wavelength is so small. You don't have any observable effect actually. Even though you might had a pattern, you can't observe that one at all in case of bullet. They are so close to each other. Fringe width is too small to be observed, so that you will find continuous pattern. That I haven't quoted because I was concentrating on this one. Is that okay? I mean, you better to read out Feynman lecture, suppose if you need, okay? Yeah, so check out if any questions are there, okay?
Sir, Anjulan said, if we observe the system without disturbing it,
No.
still pattern would be same.
How do you observe the system without disturbing the system? I will come to that point.
It's impossible.
It is impossible to observe the system without disturbing the system. This leads to the new theory, remember. Without observing the system, you can't, do any measurement.
How to do experiment?
No, you can't do any experiment. So that's why you should do measurement. And you should develop your theory according to measurement outcome. What is there before, it is immaterial. I get my point. You should develop the theory according to measurement outcome. There is nothing predefined. If that is predefined, how do you prove? If you do the measurement, if that measurement doesn't disturb the system. Okay, wait a second, I'll come to that point. Okay. These kind of ideas lead to building the theory. Okay. Now look at here, we are getting into a linear differential equation which allows this one. Suppose this is a solution, this is another solution. If you linearly combine them, that's also solution for a single particle.
That should be solution.
That is also solution. That's the property of linear differential equation. That's why Schrodinger formed one linear differential equation, which allows superposition of states. Is that clear?
Okay, sir. Okay.
Yeah. So this is the idea. So we shall try to get a deviation. Yes.
Sir, the production of wave functions is only due to the disturbance created by the photon, right?
Yeah, a collapsing of the wave function is because of observation or measurement. You can say like that.
Yeah, I mean, it's only because of the photon that disturbs due to its momentum. That's only the reason behind this collapsing of.
No, when you do observation, there is no way you will get this one. That's what I'm saying. Suppose if you toss a coin, okay, the result is either head or tail, isn't it?
Yes.
That will be revealed only after you toss it, only after it falls on the ground.
When the coin is in the air, it's in superposition.
Yeah, it is in superposition. When coin is in the air, it is in superposition state.
When it's in your hand, you can't say which one is this.
Yeah, suppose you toss the coin and put it inside the hand. You don't know which it is, what it is. Or suppose it is in the air, let me take like that. It is in air and it is falling, okay? So only after after it takes one of the stand, okay? So you can say that this is either head or tail. Before that you can't say whether it's going to be head or tail, okay? So that's why, even there is no possible way of observing this one, okay? Observing some consequence of this one, observing by doing some observation. This consequence will be there as a result of something else. I mean, this will lead to some other.
That explains that interference.
So this one show itself as some other experimental outcome. Superposition state. So that will manifest itself as some other thing. That is our interference pattern here. So again, definitely you will get either this one or this one.
So that also interference pattern or not?
No, this is not interference pattern. This is not interference pattern. But in case of bullet, we draw like this, but it contains interference pattern very close to each other. Yeah, just forget.
How do I convince that which pattern is this? It's like Gaussian wave function or what?
Yeah, similar to that one. But again, look at here. This is just P1 plus P2. That's what I have written here. What is this pattern? This pattern is P1 plus P2. This is continuous pattern. In case of bullet, when bullet is unobserved, okay, you get similar pattern, but it might have contained small, fringe width, but those are too small to observe. That's why I told don't go for that kind of idea to say whether it is big or small. Okay, while saying whether it is big or small, don't go for wave nature or some whether it follows interference or something, isn't it? We may not observe that one. Okay, in case of bullet, we may not observe wave nature may be there, isn't it? We don't observe that one, isn't it? We don't observe in case of bullet. Okay, yeah. So now look at here. This is the mathematics. When you observe, you get either this one or this one. When you toss the coin, okay, when you observe, you will get either head or tail. When you are not observing, it is in the superposition of head and tail.
The first translation is straight cyber. So why it can't be cyber square?
No, I think he wants to say.
No. It all started with this one. Look at here. Prior to probability, we defined something. Later we said this is a translation state.
He wants to say, I think, differential equation linear.
No, not that one. He is saying why state is mod psi 1 square. Why can't you say mod psi 1 square is directly the state?
Yes, sir.
Okay.
Mod psi 1 square gives you probability, but that is not fundamental. Have you seen? Again, go to optics. Electric field was more fundamental. Then you get intensity, isn't it? That's why that fundamental quantity we call that one is probability amplitude, even though it has no physical significance. It has no physical significance. Is that okay?
Yes, sir.
It has no physical significance, but it is more fundamental because look at here, you got a rule of adding probability amplitude. Okay, very simple rule, isn't it?
So we have just cut and paste the idea of wave optics.
Wave optics, nothing else.
Okay, sir.
Yeah. Now I'll go to other concept here. Is that okay? Yeah. So just so check out if any question. So when you observe, this would happen. I'll try to put this thing into notes. Okay. So state of the particle can be psi 1, state of the particle can be psi 2, state of the particle can be psi 1 plus psi 2. Okay. If you do observation, you will get these two. If you do observation through which slit is passing through, this will not be manifested. You will never observe that both electron passing through both slit or something, or electron splitting into two both slit. You will not observe any of this. Okay. So these are the ideas.
Sir, observation.
Now look at here. Yeah. Observation. Speak out.
Observation through which the electron is passing, and through which the slit is passing, only collapses the wave function, right?
Yeah.
If we observe angular moment of the electron, then will it also collapse the wave?
Yes. Again, when you observe, we say that one is collapsing of the wave function either to psi 1 or to psi 2.
Yeah, I mean, it's not observing through which the slit electron is moving, only observing the angular moment of the electron. Maybe anything, any properties of electron.
No. Here, look at here. Which observable you are observing? What you are observing, that also important in quantum mechanics. Whether you are observing energy, whether you are observing angular momentum, whether you are observing linear momentum, you will get one of the answers. Are you getting my point?
Yeah, I mean, after that, will it also collapses the wave function?
Yeah.
Because
So
we are not getting any result whether it's coming from slit 1 or slit 2. We are only getting a result that it's only having an angular momentum.
yes, no. Here we are not interested to again in this experiment. Okay. Later I am going to generalize. In the next class I am going to say the state is a superposition of momentum state. Okay. Then if you observe momentum, you get one of the momentum. But since it is a superposition of two translation state, here we are interested to observe through which slit it is passing through, and it will show off one of that one. It will show off one of that. Now look at here. This superposition state will introduce a kind of indeterminacy in quantum mechanics. Okay, indeterminacy means, look at here, without observation you don't know, isn't it? You don't know what's going to happen. Suppose if you are observing, okay, suppose if you got first electron pass through slit 1, you can't say next electron pass through slit 2, isn't it? So again, once it is in the superposition state, look at here. Again, if you do observation, either you get this one or you get this one. You can't say before measurement you get this one or this one, isn't it? Before measurement you can't say anything, isn't it? That's a kind of indeterminacy.
Yes.
Again, this superposition state, this superposition principle in quantum mechanics, that will introduce a kind of indeterminacy in the theory. This is not deterministic theory. You can't say anything before measurement at all.
So what do you think? Is it evaluable?
Hmm?
It will be evaluable?
It is evolved already. That's why you need to believe. Okay? Yeah. So what I am saying is this one will introduce a kind of, I say uncertainty. Okay, but not Uncertainty principle, okay? Get here, uncertain. The superposition state says uncertain. Well, again, it can be either pass through slit 1 or pass through slit 2. Again, we don't know. Only after measurement you will get to know. Isn't it? The superposition state also leads to uncertainty. It's uncertain through which slit it will pass through. Isn't it? Indeterministic. You can't say before measurement, you can't say anything. But in classical mechanics, before measurement also you can say at this time particle is going to be there. If you know the force acting on the system, you can solve Newton's second law. You can say at this point particle is going to be there with this momentum. Particle will occupy this point in the space with this momentum. You can say, after you can observe and we can verify. Even before measurement you can say this is going to happen, but here not like that. Is that okay? So that is the what you call deviation from what you call classical mechanics. Okay? So just read out if you have any more questions.
Sir,
Yes.
Muhammad asked, the arrangement is to produce two coherent sources. Is it? They are different only in their phases, are not they?
No, wait a second. We shall talk about that coherency of light source later, okay? I too told, am I right? Applying whatever file you shared, that's also not talking about uncertainty of photon, okay? He talked photon separately, he talked uncertainty, he applied uncertainty to particle, not photon. Whatever the MIT lecture you said, okay? I'll talk about that one later, okay? Uncertainty, how to apply uncertainty to photon, how monochromatic photons can be, like that, isn't it? That kind of question.
Sir, one question here.
Yes.
Faisal asked, sir, when we observing the probability to find on screen, electrons is higher or we not observing, then probability will higher. Because if we observing then, or sure not much electron will reach on screen.
No. Electrons will reach, but its path may be deviated much.
Okay.
When you observe, when you hit that one with a photon, electron will reach the screen, okay? I think it is stuck on. Time 6:54. Little bit noise is there in YouTube. Keep volume little low. Okay. Yeah. Let me proceed. Okay. Now look at here. I asked the question: what is big? What is small? You found any answer? Or again, we say for big particle we can apply classical law. For small particle, we can't apply classical laws, isn't it? Isn't it? Now, again, how do you quantify that big and small? How do you, give the definition for big and small in an absolute way without doing any comparison? Remember, without doing any comparison, the absolute meaning of big and small we need to find. Then I think we will get our answer, how to proceed with the theory. Yeah. So, any answer quickly on Google Meet?
Sir, by finding de Broglie wavelength and comparing?
No, not de Broglie wavelength depends on momentum also, okay? Not only mass, size or something, it depends on momentum also. That's why you can vary de Broglie wavelength by varying velocity or momentum. So come out of that one, because de Broglie hypothesis, yeah, it is the motivation, but it didn't give us much idea, okay? Come out of the de Broglie idea. So we are going to use that one to say whether quantum mechanics is applicable or not later, okay? But not in this sense, okay? In a quite slightly different sense.
One good question. Kartik asked, sir, if measurements made on state 1, if electron is in superposition state, does measurements affect on state 2?
Measurement made on state 1 means you are saying that it is in state 1. If you do the measurement, you get state 1 only. That means you are blocking slit 2. All electrons reaching on the screen, they are definitely in state 1. Is that okay? You said measurement on state 1, isn't it? Already it is collapsed.
Okay.
Already it is one of the definite state. One of the possible state.
Define it.
Definite state. One of the possible state. Definite. If you close the slit 2, it is in the definite, all electrons which are reaching the slit, they are in the definite translation state, that is translation state that pass through slit 1. That's a very good question.
Definite is
Huh.
the answer.
Yeah, definite state. It is in the definite state, then it's again you will not observe any pattern which is because of superposition state and all. Is that okay? Similarly, if you close slit 1, all electrons reaching the what you call screen, they are in the state psi 2. Definite state. Again, you definitely know. You don't have to even observe. Without observing, also you know that one. Yeah, it is in that state. I get your point. This is again, so only superposition state introduce indeterminacy, not a definite state. You can prepare a system with definite state. Close one of the slit. Those are definite state. Is that okay?
Electron diffraction happens through single slit.
Yeah. Wait. Again, here I have taken slit width is so small. Again, I'll talk about the diffraction little later. Okay, in case of uncertainty, there is also superposition kind of thing is happening. Superposition of different momentum state is happening. So let me talk about that a little later. Okay, next session I think. Okay.